Bismillahirrahmanirrahim. Welcome to computational physics class. This video is a part of lecture series on programming in C++. In this video, we will discuss about functions. There are two types of functions. One is system-based and the other one is user-based. System-based are the built-in functions which are programmed by the programmers, system programmers, while the user-defined functions are made by the user for specific problems. First of all, introduction of the math.h, another function, the header files math.h, which has a number of functions. All the mathematical calculation can be done in C++ programming language using these mathematical functions which are present inside a built-in function or a built-in header file present in the library by name math, and extension, by giving the extension math.h, we can include that header file in our program and can use a number of functions which are present over there. For example, written over here, a sine function, uh, having a syntax over here, the declaration and the sine function, it would be written. There are several number of functions present in the library of math.h. This is used the exponential. Anything we want to use in the want to have the exponential of that value is written inside the round bracket, and this exp with 2, it is used when we want to calculate any number which is 2 raised to power something, the number or the power is written inside the round bracket. Another function, it is used for exponential, having minus sign and minus, and in between any number, its exponential can be calculated by using this function. These are the two for the log. One is for the natural log and other is for the base 10 log. So this is the syntax of it. This is very important. In order to have a power of any number, we use this function. Inside the round bracket, we write the variable, and with the separated by comma the power, so it calculates the power. This abs, it gives us the absolute value of an argument. CBRT, it is the cube root of a number. This function is, this command, this function is used for the calculating cube root of the function, and this returns the integral value nearest to argument, that is, it rounds off the value. This function is to calculate the square root, and the remainder of this division will be given by this. If you use this function, it will give you remainder of any division. Several other math.h functions. These are the sine, hyperbolic sine, sine inverse, hyperbolic is similarly cos, related to all the cos, hyperbolic cos, cos inverse, and the tangent. These are all for the sines and cosines and for the tangent. If we want to use these in any of our calculation, we can utilize these built-in functions which are present in the math.h library. The thing which is required to be done, you have to include this header file into your program, then you can utilize these. There are also many number of arithmetic functions that can be utilized. So by including this header file, you can use all these functions. Now let's consider certain examples of math.h library functions. Here you can see an example program in which sign of x is used. You can see the first variable is declared and initialized, and by using this function you have included the file. So you can use this function and it will calculate the sign of x, which is 45.3, and its output is this. This is for the cosine function. Here this cosine function has been used, and by using this cosine function you can calculate. Now let's see the square root. For the square root, this variable having a value 25, it is not necessary to introduce a variable. Then you can calculate a function. If you directly write 25, it will also give you an answer. This is another power function. This is the base and this is the exponent. So 3.4 raised to power 4.4, it will be calculated by this, and the result will have the value of this function. The function which will return a value, it will be stored against this variable result. Now this is for the logarithmic of the base 10. Base 10, this function has been used in x. We can introduce, you can directly write 13.056 instead of x, it will give you the same answer. Now this was the built-in function, and one of the built-in function math.h, which we usually required for all the arithmetic operations. So it was introduced to you and certain examples were described. Now here comes the user-defined function. User-defined functions, they are made by the user in order to solve some specific problems. There are number of multiple parts or multiple parts of user-defined function. In order to establish that user-defined function, it comprises of these four parts. First part is function declaration or the prototypes. Second is the function call. Third is function definition, and the fourth one is return statement. So let's see these four parts of the user defined function one by one. First of all, function call. The statement that activates a function is known as function call. The following steps takes place when a function is called. What following steps? The control moves to the function that is called, and all statements in function body are executed. Control returns back to calling of the function. It means that after execution of the statements inside the body of the function, the control is transferred back to the place where it was being called. Next is the function declaration. In the function declaration is the model of a function. It is also known as the function prototype. It provides information to compiler about the structure of the function to be used in the program, and it is always ended by semicolon, and it consists of function name, function return type, numbers, and types of parameter. Here you can see the syntax of function declaration. Return type, it indicates the type of value that will be returned by the function. It is the name indicating the problem. If you are making the function for calculating sum, so the function name should indicate that this function is related to that specific problem. And inside this, parameters are the values that are provided to the function when the function is called. So these parameters, these the values are given to the function. So this is the syntax of function declaration. Now as I have mentioned earlier, the calling of the function, it consists of this form. You can see over here. Here is the void was the function, it was being called. Void here is the calling of the function void, which is a built-in function. Here is another function fun. This function is user defined function, and this statement is calling of the function. When you call the function inside any main function, the control is transferred to the definition of the function. Now let's see the definition of the function. It is a set of statements that explains what a function does. uh, it means that when the control is transferred from the calling of the function to the definition, it includes all the statements, and it has to return a value to that calling at the place where the function was called. And it is not necessary to write the function definition before main function or after main function. It could be written before main function or after the main function, or it could be written in a separate file. So it is not necessary to place the function definition in any specific place. So this is the syntax of the function definition. Here, the return type, what type of result this function will return, its data type is written over here, the function name and the parameter. Here you can see the semicolon is not written over here, and this statement is quite similar to the function prototype, with the difference that semicolon is not here. Semicolon is written with the declaration or the prototype of the function, while in the definition we don't write the semicolon. And this is the body of the function definition. It consists of a body of the number of statements. So whenever this function is called by its name, the control is transferred to this definition. All these statements are executed, and at the last, a return statement will provide a return or a value or expression after executing the body of the function. So the return statement returns the value and transfers the controls to the caller, which is calling the function. There are three ways to return control. First, this one. This return statement does not return any value to the caller. It just executes the number of statements which are present inside the body of the function. And this statement with an return expression, it will return a value of expression to the caller. While return 0, this return statement indicates whether the program is executed correctly, and we, as main function is also a type of a function, so we usually include return 0 in order to ensure that the program has been executed correctly. Now here comes an example by which you can clearly understand the user-defined program function. It's a program that uses a function to calculate and print the area of a square. A square area has been calculated by using the function. Square name, function name is used, and these are the parameter. This one is the function prototype. After that, the second part is the function call. Here is the function call. Next comes when the function is called, its control is transferred towards the definition of the function. And after executing all the statements inside the body of the function, return, this is the fourth part, return will return a value. Here is S, it will return a value to the caller. This is the caller. Let's examine it line wise. First, header file was included. This was the prototype of the function, that was a square named as square. It should return an integer, and an integer value through a single variable is passed as a parameter. Start of the main function, first two variables x and square, two variables are introduced. X is the parameter in order to calculate the square. It can be used in order to calculate the square area. it is length square, as the four sides are equal, so the area is equal to the length square. So for the length we are using a variable x. First the user will enter the value of x. After that this square will be calculated. The function is being called of the square function, and this square function will transfer the control towards the function definition. Here this square function definition is present inside this body of. Here a, the parameter, is used. A will get the value of the x which are being used by the which has been inserted by the user. So a will get the value of x. After that another variable s is declared. S value is used to return a value, as the function, the prototype shown over here, it has to return an integer type value. So we have introduced a variable s where its value, which is integer type, will be returned to the column. So it will calculate the square, the expression over here, it is calculating the square area of the square, and this value is transferred to the return statement, and the return statements transfer the value to the column, and this value of s will be stored against sqr, the variable, and the variable its output will be shown on the screen, and after that the programs end. So this is how the user defined function works. By showing a simple program over here, I have illustrated a user defined function which is named as square. Now, function scope rules. Identifiers declared in the outpost block of a function have function scope. They can be accessed only in the function that declared them. Labels, which are identifiers followed by a colon, have function scope. Label contained in a function can be used anywhere in that function but are not visible outside the function. If you are using any variables or parameters, they are all accessible inside that function. Outside the function, they are unknown. So there are certain scopes of function. Uh, we can assess a function can be assessed by the scope of the function. There are two types, that the local functions and the global function. A function that is declared in another function is called a local function, and while the global function, a function that is declared outside any function, is called the global function. So this was all about the function. Thank you.